Let's review how we classify our triangles based on their sides and angles. So take a look at this first one. If two sides have the same measurement, what was that word Mrs. Feynman used in class when two sides have the same length? Those two sides are, that's right, those two sides are congruent. So if a triangle has two congruent sides, then we can refer to our triangle as isosceles. Now, looking at the angles, if I'm looking here at my measurements, I know that I don't have a right triangle because I don't have any right angles and I don't have any obtuse angles. So this must be an acute triangle. Remember, it only needs to have one acute angle in order for it to be an acute triangle. Now look at number 2 here. I know that this angle in here is 100 degrees. So if it's 100 degrees, how do I classify this triangle based on the angle? Yep, this would be obtuse. Now, if it's obtuse, I want to look and see if this is 30 degrees and this side over here is 50 degrees, then I know all three of these sides are going to be different lengths. If all three of the sides are different lengths, then we call this a scalene triangle. And the way you can think of scalene is like it leans over. Okay, look at number 3. If all three sides of the triangle are congruent, how do we classify that triangle? That's right, this is an equilateral triangle. We can also say if the sides are congruent, then our angles are congruent. And remember, if our angles are congruent, we call this an equal angular triangle. Equal angular. Let's look at our next one, number 4. How do we classify number 4? If all three sides are congruent, all three angles are congruent, how do we classify that? So here we have an equilateral. It's also equal angular because our angles are all the same, and it's also an acute triangle. So it fits into the acute category as well. If you had put acute up here, because we know all of our equal angular triangles are also acute. That's also correct. Just don't forget equal angular as well. Let's look at number 5. How can we classify number 5 based on its sides? If two of the sides are the same, then this is an isosceles triangle. And then we also know here it's not obtuse, it's not right, so this has to be an acute triangle. Okay, let's take a look at our last one here. Let's take a look at our sides. Now remember, if we have two angles that are the same, then we also know our two sides are congruent. So this as well would be an isosceles triangle. And for my angle, I see it's a right angle, so it has to be a right triangle. Down here, if they all have the same letter, then we know that they're the same type of triangle. So this would be an equilateral as well as equal angular triangle. Let's look at number 2. if we have one side that's the same, that's different, and two sides that are the same, remember, two sides that are the same are isosceles. And we can also see that we have one obtuse angle. So it's an isosceles obtuse triangle. Let's look at number 3. What does number 3 look like? Looks exactly like number 1. So yes, this would also, just like number 1, be equilateral and equal angular. How about number 4? What kind of triangle is this? Anytime we see that, we see it's a right triangle, and we have 3 different letters on there. So we know our sides are 3 different lengths. So this would be a right scalene, or scalene right. It doesn't matter which order you write those in. Okay, let's take a look at number 5. 2 sides are the same, and all 3 angles are acute. So we have an isosceles acute triangle. And let's take a look at number 6. This one looks awfully close to number 2, but look, all 3 sides are a little different because the letters A, B, and C. So of all 3 sides, this would mean that this is an obtuse scalene triangle. Check yours with mine. Pause the video if you need to write those down. Remember, number 1 and number 3 matched. How many degrees are in a triangle? There's 180 degrees. So to find those missing measurements, you need to add up the 2 degrees that they give you here, and then subtract from 180. So for this first one here, you should have gotten 72 degrees. Go ahead and check your other ones with me. Number 2, I got 46 degrees. For number 3 here, this is 60 and this is 90. So once I add those 2 up, we get 150. What would X equal here? You should have gotten 30 degrees. Okay, it looks like we skipped number 4. Let's go on to number 5. When we added those 2 up, we got 123, and then once we subtract, we get 57 degrees. Let's look at number 6. When you add those 2 up here, we get 116. And let's go ahead and subtract. We get 64, which tells me if I have 2 angles that are the same, we have an isosceles triangle. Tell me what you got for number 7. You should have gotten 72 degrees there. Okay, let's come down and take a look at our formula for the volume of a cube or rectangular prism. So remember, our volume is our length times our width times our height. Let's take a look at our volume of our cube. If we're going to use that formula, then remember, it's a cube. So if the height is 5, the length is going to be 5, and the width is going to be 5. So we need to multiply 5 times 5 times 5. When you multiply that here, we get 125 inches cubed since it's area since it's volume. Okay, let's take a look at our next one here. How would I find the volume of this shape? Here, we can tell it must be a rectangular prism because it has different measurements for the height, the width, and the length. That's right, you would find it by multiplying 20 times 9 times 7, which would give us 1,260 inches cubed. Let's take a look at our shape here. This is a cube. It's a little hard to see, so remember how we talked about in class, if you go get a cube and look at it, right? We know there's a face on the top and the bottom, and 4 around the sides. So we have. Now let's talk about the edges. Remember, the edges are where the two faces meet. So I have 4 edges on each of my 2 ends. If you're holding a cube, it's easier to see. And then connecting, right? I would have 9, 10, and 2 more on the other side to give me 12 edges. My vertices are those corners. So if I have 4 corners on each side, that would be 8 vertices. My next shape is my sphere. And remember, this is rounded, so rounded surfaces means there's no faces, there's no edges, there's no vertices. Think about our cone now. So a cone is rounded on the bottom, so there's only one face on the top. I don't have any edges because it's rounded there. And my vertices, I only have 1 point at the bottom. This is a tricky one. Remember, this is a triangle shape, and we said if it meets at a point, it's a pyramid. So this is a triangular pyramid. And my faces, I have 3 along the side and 1 on the bottom. I have 4 faces. My edges, remember the edges are those sides there. I have 3, 4, 5, 6, and 3 on the other side we can't see there. So we would have 9 edges. My vertices, if I'm looking for those corners, I have 3 on the bottom and 1 on the top. So I would have 4 vertices there. Oops, I think I counted too many edges on my triangular prism. This is actually 6. Fix that there. You don't need to know these. You just need to know the names of the shapes. You don't need to know the faces, edges, and vertices for the test. This next one is a rectangular prism. So our rectangular prism is just like the cube. So it has 6 faces, 12 edges, and 8 vertices. What's this next shape called? Looks also like a coffee cup. This one is a cylinder. So on our cylinder, remember, if it's a curved surface, it's not a face. So we just have the top and the bottom, so 2 faces. And since it's curved here, we don't have any edges or any vertices. Now that you're finished watching this Ed puzzle, you can go ahead and start on your math space homework. You have tonight and tomorrow night to get your math space finished to get ready for our test on Friday. Thank you.